When I saw the XScoreKey slides from 2008, I had a strong deja vu feeling about a system I developed a decade earlier called Network Radar, and in particular, a presentation I gave in 1998. Did the NSA or its contractors steal my work? I'd like to think so, but I suspect it's just a case of independent development. I believe now, as I believed almost 20 years ago when initially developing Network Radar, that this is the right strategy for tackling this class of problems. That is, where the signal of malicious activity is subtle and spread across space and time. And if it is the right strategy, then it isn't surprising that others discovered the strategy independently. For now, though, I'll just believe I was 10 years ahead of the NSA. Why this video? I know nothing about the various NSA projects other than that The Guardian has published. But by talking about Network Radar from the 1990s, its application to cyber defense, and its similarities to the NSA slides published so far, it may shed a little light on what the NSA is doing and why. Most of my slides that I'm showing here are from a DARPA presentation in Aspen, Colorado in 1998. The slide that first caught my eye was XScoreKey's slide 11. It was, for all practical purposes, a strawman diagram of Network Radar's primary tool, Network Radar Audit Trail, or NRAT. See, the creators of XScoreKey even stole my habit of giving their system a crappy name. The key to XScoreKey is the plugins to extract metadata from the raw network sessions. What is metadata? It is a technical term that means any damn thing you want it to mean. For our purposes here, though, it is some smaller, structured set of data that captures some aspect of the original data. By being smaller, you can keep it around for a lot longer than the large amount of original data. And by being structured, you can store it in a database, search for it, and apply additional automated analysis tools to it. To be more concrete, let's look at some of the metadata I was using in Network Radar. This slide shows the basic components used to construct two different network monitors. Packets come up from the bottom network taps, and each network session is then identified and analyzed by its own stack of stream modules, what XScoreKey calls plugins. Here is one set of metadata for an FTP connection. The general connection metadata is at the top, and below that is the metadata specific to FTP. Here we see the names of the files uploaded to the server. Here is another set of metadata for a telnet connection. In this case, there were 4 mini-sensors or plugins. Again, at the top is general metadata about the connection. Below that is metadata about the telnet protocol, login information, and strings matched in the data. Here's a GUI front end to the metadata. Connections are identified at the bottom, and selecting one shows across the top the metadata extracted by each of the mini-sensors. In an ideal world, our metadata would perfectly capture everything we needed to know about the original data, and we would never need the original data again. No human would ever have to look at the original data. Unfortunately, we don't live in an ideal world. In slide 2 of the XScoreKey slide deck are these 2 lines talking about full take data and series of viewers. What does this mean? Well, in Network Radar, I had the option to save the original network packet data, and if necessary, view that data using different viewers. I suspect that is what this XScoreKey slide is talking about. For some concrete examples, let's return to the GUI front end to the Network Radar metadata. At the bottom are 3 buttons to pull up some of the original data using different viewers. The transcript button extracts all the input bytes and output bytes from the packets and displays them in a window. You can think of the top view as what the person typed and the bottom view as what they saw if it was printed on a roll of paper. If you use the early versions of the Air Force's ASIM or DIS's JIDS network sensors, this view is basically the same as the transcript tool in those systems. The replay button brings up a VCR-like controller and a window that mimics the original user's terminal, complete with correct screen size, cursor movement, and timing information. The byte stream button brings up a window showing each byte from the client and server on their own lines in 4 different formats. This was my favorite view and dead useful for analyzing low-level attacks against anything above the TCP layer. So what is the value of all this metadata, and why do you want to keep it around for so long? There are two somewhat intertwined value propositions for the metadata: search and statistical analysis. Slide 20 in the XScoreKey slide deck points out this search example. XScoreKey extracts and databases these events, including all web-based searches, which can be retrospectively queried. A more concrete example comes from a 1997 summary of Network Radar I wrote and later found published on a PRC website. For example, if you discover a Trojan login program which allows an attacker to log in by simply supplying the password BAA9711, you can search through your audit logs, metadata, for every time the string BAA9711 was used as a password. It is important to note that unlike existing monitors, NSM, NID, ASIM, NetRanger, etc., you did not have to previously direct your monitor to look for the string BAA9711. You can search for the string after the fact. In other words, a retrospective query on the metadata. There is a long history of cyber attacks using this very technique, including one built into the original C compiler for Unix. In cyber defense, quite often by the time you detect, or more likely you are notified, that intruders have a foothold in your organization, they have already been there for months, or maybe even years. Having retrospective search capability can be extremely valuable in cyber defense. I suspect the same might be true in the intelligence world. Slide 10 in the XScoreKey slide deck hints at a statistical analysis example. We can use this traffic to detect anomalies which can lead us to intelligence by itself. Again, for a more concrete example, I return to Network Radar. In the picture of the mini sensors, the ones labeled thumb created a thumbprint, today I would use the word fingerprint, for part or all of the connection. A thumbprint is a small numerical representation of the data. Once I had the thumbprint, it was very easy, for example, to measure how frequently I saw the same content flying around the network on multiple connections. I was running my system at the Air Force's Rome Labs on May 4th, 2000, when there was a huge spike of connections, all with nearly identical thumbprints. That spike was the I love you, or love bug, worm spreading across the internet. I love you was one of the earliest destructive worms to hit the internet. By clustering on thumbprint metadata, I could track when the worm initially hit Rome Labs, peaked in its activity, and eventually burned out. But why do they need to collect the full take data? Isn't that being intrusive? Again, let's return to my own system for a concrete example. In May of 2000 at Rome Labs, I was only collecting the metadata from the network traffic, not the full packet data. My system could easily detect the huge spike in repeating thumbprints across the network, but I didn't know what it was. I had no ground truth. In the case of the I love you worm, I got lucky because I personally received the worm in my own email. I calculated the thumbprint on the email I received and plotted its value on the graph, the red circle on the x-axis. Sure enough, it lined up perfectly with the spike at Rome Labs. But there was also a second, smaller spike of thumbprints at the exact same time. I never had ground truth, no actual data to match to this spike, so its underlying cause will always be a mystery to me. There are a number of reasons that you want full take data, but having ground truth to understand the underlying activity behind some suspicious signal is a critical one. In the 1990s, I was developing a system called Network Radar for cyber defense that was eerily similar to the NSA's XScoreKey for intelligence. We both analyzed network traffic, we both extracted metadata via mini sensors, we both inserted that metadata into databases on which we could perform retrospective queries or perform various statistical analyses, and when there was a suspicious signal in the metadata, we both had viewers to look at the original data to understand the underlying cause for that signal. Almost 20 years after starting on Network Radar, I still believe that that strategy is the correct one for detecting and analyzing advanced and subtle threats where the evidence for the threat is spread across space and time. Thank you.